Okay, so welcome to section 1.7, which is inverse functions. Inverse functions. Okay, so let's recall one-to-one functions. So one-to-one functions have graphs. Graphs which pass the horizontal line test. Which pass the horizontal line test. Meaning a function is one-to-one if any horizontal line intersects the graph in at most one point. So that is the function is one-to-one if any horizontal line intersects the graph at most once. So meaning no more than once. If it intersects twice, it is not one-to-one. Okay, so definition. Okay, so the inverse, that's what we're defining, the inverse. The inverse of a function, f of x, denoted by f with a -1 up top of x, so this is read aloud. So read aloud f inverse of x. So that is the function. So is the function which undoes the function f of x. So that is, i.e. id est, i.e. if I have f of x and I apply f inverse to f of x, meaning I take the composition, f inverse will undo what f has done, and you'll just get back x. So let's note another way to define the inverse is that for all points x comma y on the graph of f of x, this implies that y comma x is on the graph of f inverse of x. So I'm swapping, that is, we swap x and y. So i.e. id est, we swap x and y. So what was the first coordinate is now the second, and vice versa. Okay, another way of saying this, how shall I do this? This implies that the domain of f of x which is all inputs x, will be the range of f inverse of x, because now all of my x's become y's and vice versa. So hence the range of f of x, the y values that it outputs, will be the same as the domain, pardon me, of the inverse function, meaning the inputs. Okay, so there's a caveat or a warning, like Kawe Kanam, so caveat, warning, beware. Okay, f inverse of x is not the same as a reciprocal. So because it's a function, not a variable, this is not 1 over f of x. And that's because, what color should I use? And this is because f of x is not a variable. So that -1 does not mean 1 over, as it would say for x to the negative first power. Okay, so now let's list, how do we find the inverse? So finding the inverse of a one-to-one function f of x. Okay, so the first step is we let y be equal to f of x. The second step is that we swap x and y, and at this point we have effectively enacted the inverse, but we want to solve. So number 3, solve for y, because that will be your inverse function. So solve for y. So once we've solved for that y, we let that y be f inverse of x, because that's what it is. So for example, so find f inverse. So find f inverse of x for the following functions. Number 1, we have that f of x is 2x plus 3. Okay, so step 1, we want to let y be 2x plus 3. So I'm replacing f of x with y. Step 2, I'll use green. Step 2, we swap x and y. So we get x is equal to 2y plus 3. Notice I've just swapped x and y. Step 3 will be to isolate y. So first let's do x minus 3 is equal to 2y. And then we'll divide by 2. So 1/2 x minus 3/2 is y. And then finally step 4 is to call that y f inverse of x. So f inverse of x is 1/2 x minus 3/2. Okay, so that is our inverse function for number 1. So subscript number 2. Let's say we have that f of x is a rational function. So that is, say it's x over x plus 5. So step 1 is to replace f of x with y. So we get that y is equal to x over x plus 5. Step 2 is to swap x and y. So this now becomes x is equal to y over y plus 5. Step 3 is to isolate y. So the first thing I'm going to do with the above is I'm going to multiply or cross multiply. So I'm just going to multiply x by the denominator on the right hand side, and then I'll distribute So xy plus 5x is equal to y. And then I'm going to swap places between these two guys. So I'll subtract each. So xy minus y is equal to negative 5x. Then I'll factor the y out from the left-hand side. So when you factor, you divide each term by what you're factoring out. And then finally, I'll divide through by the factor x minus 1. So I'll have negative 5x divided by x minus 1. And I've finally isolated y. So final step, number 4. I replace that y with f inverse of x. And that will be negative 5x divided by x minus 1. Okay, let's do one more of these. So subscript number 3. Actually, I should probably move those to the right a bit. That looks a bit better like that. Okay, so subscript number 3. Let's say we have that f of x is equal to the cubed root of the quantity 6x plus 12. And you know what? No, I don't like that. Let's do 12x plus 6. Maybe. Will that be better? I don't know if it will, but let's find out. So let's do the square root of 12x plus 6. No, it won't be better, but that's okay. Okay. So step 1. We let y be equal to the cubed root of 12x plus 6. That is, we're replacing f of x with y. Step 2, we're going to swap x and y. So now we get that x is equal to the cubed root of 12y plus 6. In the next step, we're going to isolate or solve for y. So the first thing I'm going to do is cube both sides. So if I cube the left-hand side, it becomes x cubed. On the right, I undo the cube root. So now let's subtract 6. And finally, let's divide by 12. So I get 1/12 x cubed minus 1/2 is equal to y. Then I can replace that y with f inverse of x. And there we are. 1/12 x cubed minus 1/2. Terrible number, sorry for that. I should not make these things up on the fly. Okay, so let's see. So let's go ahead, another example. Let's plot both f of x and f inverse of x on the same set of coordinate axes. Of coordinate axes. Okay, so number 1, what do we have? We have that f of x is equal to 2x minus 3. Okay, so step 1 real quick. Y is equal to 2x minus 3. Step 2 would be x is equal to 2y minus 3. Step 3 would be x plus 3 is 2y. Then divide by 2, I would get 1/2. Maybe I should not skip. So 1/2 x plus 3/2 is equal to y. So step 4, I get that. Maybe I'll put it here. F inverse of x is 1/2 x plus 3/2. Okay, so let's go ahead and plot these x and y coordinate axes. So 1, 2, 3, 1. So x and y. 1, 2, 3, 4. 1, 2, 1, 2. Okay, so let's say the first f of x is 2x minus 3. Well, that has a y-intercept of negative 3 and a slope of rise 2, run 1, rise 2, run 1, rise 2, run 1. So I claim that this guy here in pink, oops, is my f of x. If I can get it to autocorrect correctly, which it doesn't seem to want to do. But anyways, here's my f of x. And my f inverse of x has a y-intercept of 3/2, or 1.5, and a slope of 1/2, meaning I rise 1 and run 2. Or rise a -1, run a -2. Okay, so I should get something that looks like so. Okay, so there's my f inverse of x. And we note something interesting. If I look at the main diagonal here, hopefully you can see what's going on. But it should become clear as we continue on. So number 2, let's do the same for, let's do f of x is the square root of x plus 4. So f of x is equal to the square root of x plus 4. So this is a trick question in a sense. So the first thing we do is we let y be f of x, square root of x plus 4. Okay, step 2 is to swap x and y. X is equal to the square root of y plus 4. Next step, we solve for y, so let's square both sides. And here is where the issue is, because a squared function is not one-to-one. It's parabolic, so we have to restrict ourselves to a portion of the graph that is one-to-one. And we will look at that in a moment. So x squared minus 4 is y. So I claim that our function f inverse of x is going to be x squared minus 4 on a restricted domain. So we're going to have to note. So need to restrict domain. So it is 1-to-1. Okay, so x and y coordinate axes. We know that that's half a parabola opening to the right, shifted left 4 units. So let's see. X and y. Okay, so my graph of f of x is half a parabola opening to the right, shifted left 4 units. So it should look something like so. 2, 3, 4, 5. So this is f of x. And I forgot to indicate down here. 1, 2, 3, 4, 5. Okay, now I know that this would be a parabola or quadratic function shifted down 4 units. But I'm actually only allowed to have the right-hand side of this function. Let me see. 1, 2, 3, 4. 1, 2, 3, 4, 5. That would be here. Oh boy. Drawing, not my strong suit. Okay, let me try and move this around, see if I can draw this a bit better. Oh, well, close enough for government work. Okay, so notice I am not going to plot the other side, right? Which I would have otherwise plotted. And the reason I know that that's the side I'm going to omit from the inverse has to do, once again, let me indicate That's f inverse of x. Holy free holy, I think that's a raccoon trying to get in. Oh my goodness. Is that a raccoon? Okay, anyways. Where was I? Well, we might have unwanted guests. Okay, so let's look at this diagonal here. And you'll notice there's a reason I chose to use the right-hand side of that quadratic versus the left. That has to do with the symmetry about that yellow line. So let's try one more, because I could have chosen the left. Okay, so let's do number 3. So let's try f of x is equal to the quantity x minus 2 cubed. Okay, so step 1 we know. We replace y, or f of x with y. Step 2, we'll swap x and y. So x is equal to y minus 2 quantity cubed. Step 3, we will solve for y. So let's take the cubed root of both sides in order to undo the cube on the right. And then we will add 2 to both sides. And finally, I will call that my f inverse of x. Which of course is just shifted up to the cube function. Okay, so x and y coordinate axes. X and y. So we have 1, 1, 1, 1. Okay, so this is shifted to the right 2. And it's a cubic, so let's go ahead, shift to the right 2. So it's going to be a nice S-shaped graph. So this is my f of x. Whereas I have a shallow S-shaped graph here for the inverse, shifted up 2. So that's going to look something like something like that. So that'll be my f inverse of x. So we notice that once again, this yellow line is important for the graphs. And had I drawn this well, they would have overlapped on that yellow line here. But I didn't draw it well enough. But we get the idea. Okay, hopefully we get the idea. Okay, so let's note, what have we discovered then? Note that the graphs of f of x and f inverse of x, the graphs of f of x and f inverse of x are reflections of one another across the line. So what is that yellow line? This is the main diagonal. This is the line y equals x. Y equals x. Y equals x. That's the line y equals x. Now, why would it be a reflection across the line y equals x? Well, it has to do with the step where we swap y and x. So each time we've swapped y and x, we've reflected the graphs about that line. Okay, so for example, if I were to just give you graphs, then without functions, so given the following graphs, given the following graphs of f of x, plot an estimate. So plot an estimate to the graph of f inverse of x. Okay, so number one, x and y coordinate axes. Let's focus more on quadrant one here. Just for this problem. So x and y. Let's say we have a function that looks like, oops, I don't know, what shall we say? Let's say it looks something like so. So this is my f of x. Then I could take the main diagonal here and use that as my mirror. So I could say, okay, it's something like so. My f inverse of x. Okay. Actually, let's do another graph right next to it. Let's say we have something that looks like, what shall we do? X and y. Let's say we have something that looks like so 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Like that, and then like what shall I do? Something like this for f of x. So it's a piecewise defined function. So it's just got two pieces here. So if I were to look at the main diagonal, which is harder to draw than you'd think, then a mirror image across it, at least down here, would be kind of easy to do, because I just follow it like a mirror. At that point, kind of like a mirror, and then I go to 3 here, go off like so. So I claim that this is f inverse, just by reflecting it across this mirror here. Okay, let's do one more, shall we? So number 3. So let's say we have the graph that looks something like tangent. So x and y coordinate axes. So now we have asymptotes. Say at plus or minus 3 again, just because it's easy. let's say the graph looks something like so for f of x. Then, since I'm swapping x and y, the graph of the inverse will have horizontal asymptotes, where the graph of the original had vertical, and vice versa. Let's go ahead and draw our main diagonal. Where is that? Okay, now we can draw the reflection like so. Actually, I don't like that drawing. I'm going to draw that a bit better if I can. Like that. And no, that's not going to work. Something like that. Okay, so that's more like my f inverse of x. Thank goodness I said estimate to the graph. Okay, and now for our final set of examples. So, example. Let's find f inverse of x and show that f composed with f inverse of x is the same as f inverse composed with f of x. And of course that should be x because they undo one another for the following. So number one, let's say we have that f of x is equal to x divided by x plus 3. Okay, so step one, to finding an inverse, we let y be equal to f of x, so x over x plus 3. Step two, to finding an inverse, is that we swap x and y, so x is equal to y over y plus 3. And that's our reflection part. Then next, let's go, I keep it here. So now let's cross multiply the denominator, so we'll have x times the quantity, y plus 3 is equal to y. Distributing, I'll have xy plus 3x is equal to y. I'm going to subtract 3x and I'm going to subtract y. So xy minus y is equal to negative 3x. Then I'll factor a y times the quantity x minus 1 is negative 3x. And finally, I'll divide. So y will be negative 3x divided by x minus 1. This, of course, is my inverse. So I call this f inverse of x will be negative 3x divided by x minus 1. Okay, so what I'd like to do now is evaluate let's do f composed with f inverse of x, which means into the function f, I'm plugging the function f inverse of x. Okay, so into the function f, I'm plugging the function negative 3x divided by x minus 1. So wherever I see an x in the function f of x, that's what I'm replacing it with. So we're going to get a complex fraction. So what we get then is as follows. So instead of x in the numerator, we now have negative 3x over x minus 1. And in the denominator, we have negative 3x over x minus 1, to which we are adding 3, plus 3. So this is a complex fraction. We want to multiply top and bottom by the LCD, which in this case is x minus 1. So we'll multiply x minus 1 and x minus 1. So distributing to the numerator, it'll reduce, and to the denominator, it'll reduce in the first fraction, but not in the second integer. So what we get then will be simply negative 3x in the numerator divided by negative 3x, to which we're adding 3 times the quantity x minus 1. Actually, I can do that in yellow so you see where it's coming from. X minus 1. I can also move this up one line. Okay, so let's go ahead and distribute in the denominator. So we will have negative 3x divided by negative 3x, then plus 3x, and then minus 3 when we distribute. And we notice now negative 3x and plus 3x sums to 0. So we're left with, in the numerator, negative 3x, and in the denominator, negative 3. Now the negative 3's reduce, leaving us with x, which is exactly what we wanted. Okay, and I'll leave it to you to show the other way, or shall I do it? What the heck, I'll do it. So let's compose. Where shall I start? Let's use a different color though. Let's use orange. So let's do F inverse composed with f of x. The cat doesn't know what's going on. There's raccoons coming in his catio. Okay, so what is this? What this means is that into the function f inverse, I'm going to plug in the function, hello kitty, f of x. Okay, so that means that into the function of f inverse, I'm plugging in, what was f of x? It was x over x plus 3. X over x plus 3. I think once the raccoons saw me, they went away. Okay, so what does f inverse do with each input? It's negative 3 times the input. I don't know if I'll have enough room here. I think I'm going to go to the next page. So let's see, let's go to the next page. So this becomes negative 3 times the input. So that's negative 3 times x over x plus 3, all divided by input minus 1. Okay, so the input is x over x plus 3, from which we're subtracting 1. Once again, this is a complex fraction, so I'm going to multiply top and bottom by the LCD, which is x plus 3. So x plus 3 in the numerator, x plus 3 in the denominator, so distributing to the only term in the numerator and to both terms in the denominator. It'll only reduce with the first term in the denominator. leaving us with, what will we get? In the numerator, we'll just get negative 3 times x. And in the denominator, we will get just x. Then we're going to get minus 1 times the x plus 3. So let's go ahead and distribute that negative 1. So what do we get? We will get negative 3x divided by what amounts to x minus x minus 3. So notice that x minus x sums to 0. And then we are left with negative 3x. So negative 3x all divided by negative 3. Which means the negative 3's reduce. And I'm left with x, check mark. It did work. Okay. So how about one more for good measure? Number 2. Let's say we have that f of x is equal to, let's do 2x cubed plus 5. So step 1 to finding an inverse, we let y be equal to f of x, namely 2x cubed plus 5. Step 2, we swap x and y, which in effect creates the inverse. Step 3, we isolate y, so I'm going to first subtract 5. Then I'm going to divide by 2. And then I'm going to take the cubed root. Okay, it's a lot easier said than done. So x minus 5 all over 2. And that'll be y. That y is my f inverse. So I claim that f inverse of x will be, I'm going to try and make my life easier, the cubed root, well, I guess it doesn't matter. X minus 5 over 2. I don't usually like fractions. I like to have the 1/2 in front, but it's tomato, tomato. So let's go ahead and evaluate f composed with f inverse of x, which means, oh, I forgot to put x. Boy, I'm really batting 1,000. Okay. Let me move this forward. So f composed with f inverse of x. There we go. Which means that into the function f, we're plugging the function f inverse of x. Okay, so namely into the function f, we are plugging the function, the cubed root of x minus 5 all over 2. Oh, wow, okay. Okay, so what does f do to each input? It cubes it, okay. So this is going to be 2 times the cube of the input, where the input is the cubed root of x minus 5 all over 2. We're going to take that input, cube it, multiply it by 2, and then add 5. So what happens when you cube a cubed root? You just get what's inside. So this is going to be 2 times the fraction x minus 5 over 2, to which we're adding 5. So note that the 2's reduce. So we are left with the numerator, x minus 5, to which we are adding 5. So now these two sum to 0, and voila, we are left with x check mark. Okay, so let's go backwards. Namely, what happens when we evaluate f inverse composed with f of x. So we're going to have the f inverse on the outside and the f on the inside. So what this means into the function f inverse, we are plugging the function f of x. Okay, so into the inverse function f of x, we are plugging the function. What is f of x? It's 2x cubed plus 5. Okay, so what does f inverse do? It takes the cubed root of, the input, which is 2x cubed plus 5. It subtracts 5 from that input, and then it divides by 2. Okay, so we can see that 5 minus 5 sums to 0. So we are left with, what are we left with? We are left with the cubed root of, all that's left in the numerator now is 2x cubed all over 2. So we can see now that the 2's will reduce, leaving us with the cubed root of x cubed. Cubed root of x cubed, which of course is just x. So we've done it. We've shown that f and f inverse undo one another. And I will see you guys in the next section.